In this example, we are given with a circuit diagram and it is asking, in the circuit shown in figure, find the power supplied by 10 volt battery and the thermal power dissipated in this 10 ohm resistance. Now in this situation, to calculate either the power supplied by the battery or thermal power in the resistance, we need to first analyze the circuit, and we have to calculate first the current flowing in various branches of the circuit. Let us consider a current I1 is flowing in the first loop and a current I2 is flowing in the second loop. And we write KVL equations to calculate the values of I1 and I2. So let us first write down the KVL equation for I1. In almost all kind of circuits, you just keep in mind whenever a circuit is given, we need to first analyze it. We write down the KVL equation for this I1 and we start from this point and move along with the current. You can see here first there will be a drop in potential of 20 volt, and then in the 10 ohm resistance there will be a potential drop of 10 I1, and then again there will be a drop of 10 volt potential, and then there will be a drop of 5 ohm resistance, that will be minus 5 I1, and this is equal to 0 according to Kirchhoff's voltage law. If we simplify this equation, this will give us 15 I1 is equals to minus 30, which gives us the value of I1 is equals to minus 2 ampere. That means actually the current is flowing in anti-clockwise fashion because there is a negative sign here. And as in the diagram shown here, we have taken as clockwise, it is coming with a negative sign. Now similarly, if we write KVL equation for I2, here you can start from this point. So there will be a gain in potential of 10 volt. Then there will be a drop in potential minus 5 I2, which is equals to 0. And on simplifying, you can see the value of I2 we are getting is 2 ampere. Now as we know the current in all the branches of circuit, we can easily calculate the current flowing in the 10 ohm resistance. Here in 10 ohm resistance, the actual current which is flowing is 2 ampere. And if we calculate the current flowing in the 10 volt battery, here you can see the current will be I2 minus I1. And in this situation, I2 is 2 ampere and I1 is minus 2, so this will be 4 ampere. Now using these currents, we can calculate the power consumed by the 10 ohm resistance and power supplied by the battery. So here power consumed by 10 ohm resistance, we can simply write it I1 square R. So here it will be 2 square multiplied by resistance, here is 10 ohms. So on calculation we are getting it as 40 watt. That will be one answer to this problem. If we calculate the power supplied by the 10 volt battery, here you can see the total current is 4 ampere, and power supplied by 10 volt battery we can write as the product of its EMF and the current. So in this situation the EMF is 10 volt and the current flowing through the battery. Here you can see one more thing, that current is coming out from the positive terminal of battery. So in this situation, current we can say is supplied by the battery. So total power supplied will be 10 multiplied by 4, that is also 40 watt. This is also the answer to this problem which is asked in it.